Well, again, everyone, welcome back to Chemistry Minutes with Mr. Rink. And today we're going to kind of do more of an advanced problem where we look at percent yield. So percent yield is very useful. Like, why do we do all this stoichiometry? Why do we do all this stuff? Well, we do it because we want to look at how well our reactions did or not. And we can do them in lab all we want, and that's actual yield. But it's the theoretical yield that we're going to use stoichiometry for. So it's a combination of both reality and in theory. So the percent yield formula is, of course, actual yield over theoretical yield. I'm going to abbreviate that theoretical, that means in theory, in ideality. Theoretical yield times 100, so it's a percent. And here's the really nice thing about all this. Your actual yield, okay, versus your theoretical yield, that should have been green, whatever. Your actual yield will always be given to you in a problem. Now, there is exceptions to that if it's an advanced problem where they want you to work backwards, but it's always given to you in the problem. This is what you get out of your lab. So let's say you do a lab in the back and you get 10 grams, then you get 10 grams. And the theoretical yield is again something that we use stoich for. So it's really interchangeable. Theoretical yield, do the stoich. So that's like grams to moles, do the stoich, back to grams. This back to grams, you're saying in theory, we can produce how many grams? So once you do the stoich, you plug in your actual, and you'll have your percent yield. So really not too bad. Okay, so then let's do a problem here. So let's take a look at this and say, okay, if we have the following equation, carbon disulfide plus 3 chlorines, this is carbon tetrachloride. All right. And if this is our equation and it's balanced, and I tell you that I have 100 grams of each, I also tell you that in lab we created 65 grams of carbon tetrachloride was obtained. When you use those words, that is code word for that's the actual yield, so we'll need that later on. So we want to know in theory how much was produced. So we're going to use stoich to do that, and that'll be our theoretical yield. Again, 65 will be our actual yield. So I can set this up ahead of time. So those of you that like to look at things better, we can show you that. A reminder, guys, in this, I'd like you to pause in a few minutes. And so our actual yield is going to be 65 grams. We're going to need to get our theoretical from stoich of carbon tetrachloride and plug it in there. Now I'd like you to try to find the limiting reactant. Is it carbon disulfide or is it chlorine? And then we're going to do the stoich back to grams. So let's pause the video and then try it and see. Don't let me do it for you. Try it out and then see what you think. Okay, well, we're back. And if you paused it, we're back. And we first need to convert both these to moles. So we're taking 100 grams of CS2 and 100 grams of chlorine. You do not use the 3 yet, just plain old CO2. We're going to divide by the molar masses. Be careful with chlorine, and there's 2 chlorines there, so even though periodic table says 35.5, 71 grams per mole for chlorine. For carbon disulfide, 76.15 about. So you're going to convert both of these to moles. Okay, and when you do that, so 100 divided by 76.15, you get 1.31 moles, 2, and 100 divided by 71 would be 1.41 moles. Now, don't forget to do that important second step, dividing by our coefficients, dividing by 1, divided by 3. This is going to stay the same at 1.31. This is going to go to a much smaller number, 0.47. So that's smaller, right? Box moles of limiting reactant. Okay, so, and maybe you didn't hit pause now, but now that, what do you do next? This is the hardest thing students do is, okay, once I have the limiting reactant, now what? We're going to use that. So go ahead and pause it, do the stoich, go back to grams, see if you can do it. Okay, well, once you've tried it, let's see if we did it right. So you would have started with 1.41 moles of chlorine. Time to do the stoich. Do the stoich as moles over moles. Remember, what you want on top is what you want on the bottom. So moles of chlorine on top, so moles of chlorine on the bottom. So you want to make sure you follow that. And what are we going to? We're going to carbon tetrachloride, CCl4, on top. The number in front of carbon tetrachloride is a 1. The number in front of chlorine over here is a 3. So our stoich is 1 over 3, or 1/3. That's it, guys. Stoich is so simple, 1 over 3. And then that puts us in moles of carbon tetrachloride. We need to go to grams. So we need to multiply by the molar mass. 1 mole on the bottom of carbon tetrachloride. We need the molar mass on top. The molar mass of 1 carbon and 4 chlorines, 153.8 about. So grams to moles, do the stoich right here, back to grams. So we do our calculations out, and we should get about 72.3 grams of carbon tetrachloride produced. So we just did stoichiometry. Congratulations, gram to moles, do the stoich. But that's not our final answer, because our answer asks for percent yield. Our percent yield is actual over theoretical. So let's go back up here. Remember where we take our actual over theoretical times 100. Our actual is always given to us of carbon tetrachloride. We need our theoretical based on stoichiometry, which is right there, 72.3. So 72.3 goes right there. Look at that, how easy that is, grams of carbon tetrachloride. We're going to divide and multiply by 100, and we're going to get about 89.9%, somewhere right around there. And that is our answer. So there you go. So percent yield is all about actual. Hey, that's a number. Theoretical, however, is indeed doing stoichiometry. Now, a lot of you, I asked for a code word, so I know you watched this video, and I know you're listening carefully, and so our code word is Bora Bora. One of Mr. Rink's bucket list things, Bora Bora, that's B-O-R-A, B-O-R-A. But I also expect that you can do this type of problem. Another little secret, if you watch this video over the weekend, we're going to have a quiz on Monday worth 30 points. Again, we're going to have a quiz on Monday worth 30 points. And I'm going to put this exact problem on the test, or one just like it, where I'm going to ask for the percent yield. So watch this. If you need to do it again, go back to the beginning, write it down again, maybe do this on Sunday night, and step by step, pause the video when you need it, and there you go. Do it as many times as you need to. You can also do number 29 or 30 in your textbook. That's, again, practicing percent yield. You've been watching Chemistry Minutes with Mr. Rink, and once again, code word is Bora Bora, and we also are going to have a quiz on Monday, and you'll know that if you watch this video. So, thanks much.